you rearrange, you can write another KC, and we have talked about how concentration of water is high and so usually you can take it as a constant. Now, I think that maybe you all don't really have a feel for what is a high concentration of, let's say, acid. The concentrated acids that you use are probably around 10 moles per dm cube to around 13, 14 moles per dm cube. That's something for like the HCl. Okay? So the stuff on the bench that you use for QA is usually 2 moles per dm cube. Okay? The stuff that you use for titration is usually around 0.1 mole per dm cube to about 0.2. Okay? So you compare them to water, which is 55.6. It's much higher. Okay? So to simplify things, since water is a large excess and it's constant, they define a new equilibrium constant, which is Ka, and this is what you have to remember. You don't need to remember how to derive this, just this result. Okay? Okay, so this is Ka, the acid dissociation constant. Now, to simplify things further, they will write it as H plus instead of H2O plus. The units are mole per dm cube. This is an equilibrium constant. Okay, so it's dependent on temperature, it's not dependent on the initial concentration. Okay. All right. Now, when we want to compare things, it can be inconvenient to compare very small numbers. For example, 1.8 times 10 to the power minus 5 compared to 4.9 times 10 to the power minus 10. Okay? So, what they do is they take negative log of the Ka value, then they get number pKa, which usually is expressed to 2 or 3 significant figures. And if you go online, you will be able to find all these values tabulated. Okay? Now, you need to try to make sense of what is a greater Ka value or a smaller Ka value, pKa value. So, look at the equilibrium. If you have a larger Ka value, okay, that will probably mean there's more H plus and A minus. The proportion of the H plus and A minus is large relative to the HA is larger, right? Okay, that means more of it is ionized. Alright? So position of equilibrium lies more to the right. Okay, greater Ka value, therefore it's a stronger acid. Okay, because you take negative log, a greater Ka value means a smaller pKa. Right, that's a mathematical thing. Okay? Okay, don't see many people. Done? Now, this one, what we are discussing is the fourth bullet point on page 9. Okay, about the value of Ka. So, ionization of a weak acid usually means that you are, okay, electrolytic fission is when a bond breaks and the electron pair just goes to one of the atoms. In this case, oxygen. So you get O minus, and the hydrogen leaves without any electrons. So it's H plus. Okay? And then it can react with the water. The water can form a dating bond with the H plus. Okay, so the main thing is that this is an endothermic reaction. Okay? So whenever you increase the temperature, you will favor the endothermic reaction. So therefore, in general, when you increase the temperature, Ka will increase. Okay? Okay? Okay, so are you okay? Ready to move on or not? You want to copy the previous thing? No consensus? Okay, so now we talk about the case for base, which is similar. Okay, at this point, I want you to focus on one thing, on this equilibrium. Okay, you look at this. When we talk about base and acid, okay, there is always this reaction with water. Okay, so you must go back to the definition and think what is the definition of a base, what's the definition of an acid. Okay, so a base is something that accepts a proton acceptor. So you have this D here that will accept a H plus and form DH plus, and in accepting that, from the water, it results in the formation of OH minus. Okay, so this is the equation that you need to write for the equilibrium. For the acid, we talked about Ha reacting with H3O plus, then the water accepts the proton with H3O plus, and then you get A minus. Okay? Now, this, again, this is the same explanation, so you will get Kb. Okay, similar. It's just that from the equation that you write, you will get different products, so it will be BH plus over OH minus over D. Okay, the Ka one is H3O plus times A minus over Ha. Okay, so the difference is you have this OH minus here for the base, for the Ka you will have H plus or H3O plus. Right? Units mole per dm cube. Okay, depends only on temperature, does not depend on the initial concentration. Okay, take log. Again, similar explanation. When you take log, negative log, you get TKB. So when Kb is greater, it's OH minus. Position of equilibrium lies more to the right. There is if you have a greater Kb value, there will be a smaller pKb value. Okay, people personally, as a student, right, I had a lot of trouble remembering this about greater Kb value, therefore whether it's a stronger base or not, and also greater Kb value, does it mean a smaller BKB? So, how I dealt with it was I used my calculator to calculate, to punch in numbers, and actual numbers. I say, okay, I have a 2 mole per dm cube acid solution. What's the pH? Okay, then I have a 0.2. What's the pH? Okay, so similar with the Ka, Kb, I will do things like that. Alright, to give you a sense of it. Okay, so take this summary. Ka is H plus or A minus H plus and A minus over HA, Kb DH plus and OH minus over E. Okay, now this part is more crucial. Okay, you need to recognize when something is an acid and something is a base. Okay. Now, for A levels, okay, I want you to listen carefully here. You have a habit of switching off about the time that I get to important things. Maybe it's because when I get to important things, I slow down, then you all think it's time to sleep. Okay, listen to this thing. At A levels, you cannot memorize whether something is an acid or a base. It depends on the situation. I can write you an equation. Nitric acid, you all know as an acid. I can write you an equation where nitric acid is acting as a base. Okay? Ammonia is typically a base. Cambridge has set a question where ammonia is acting as an acid. Okay, so you need to understand this definition very clearly. The concept here is more important than memorizing whether something is an acid or base. Okay? So this part is crucial to understanding that. Now, if you get something HA, acid, okay, after it donates the H plus, you will be left with A minus. This A minus we will call the conjugate base of HA. Okay, conjugate base of HA. Now, why is the anion called a conjugate base? It's because when you add it to water, the A minus, there will be a equilibrium mixed with the water. You will produce HA and you will produce OH minus. Okay? So A minus can accept a proton from water to reform HA and release an OH minus. Alright? Okay? So to get this, you must pay attention to what is happening. Where does a H plus go? What accepts a H plus? Alright? Okay, so A minus acts as a base. So it's a base. After accepting the H plus, then you get the conjugate acid. Why is the cation acid from a weak base an acid? It's because in water you will undergo a reaction and you will get H3O plus. Okay, so BH plus can donate a proton to water to reform B and to release H3O plus. So BH plus acts in the acid. Okay, can you do example 1.5? After the ionization is the neutralization. Okay. Okay. Now, you will notice that here water can act both as a base and an acid. So we call that amphoteric. You need to recognize and learn that term. Okay, anyway, it's printed for you then. Are you all done with this? Last one. Okay, so the key thing is that the pattern that you should recognize is this. The conjugate acid-base pair differ by one proton. Okay, so the conjugate acid, so the SK can donate, the proton can pass back and forth between the two. Alright? That's how you decide which is the acid, which is the base. Okay. Let's consider conjugate acid base pair. Okay, I want you to look at this because this one is printed for you, so you just need to understand what is happening. Can you recognize that in both the expressions there is the CH3CO minus? And in both expressions, you have the CH3COH. But it's just that it's opposite. One is the numerator, one is the denominator. Okay? So when you multiply them together, you get something interesting. The acid and the anion cancel off, and then you are left with H plus times OH minus, which is something that you recognize before. Okay? It's KW. So you get a new relationship called where Ka times Kb equals to Kw. Now this is useful because you have a value for Kw here. Okay? So Ka times Kb equal to 1 times 10 to the power minus 14. Okay, you take log on both sides, you get something more interesting, where pKw is equal to pKa plus pKb, which is equal to 14. So pKa plus pKb of the conjugate acid base pair will add up to 14. And that will be useful. So these two results are useful. Okay? Now, can you quickly do put section 1.5, the B and C? Okay? Okay, can you, for B, the only thing to take note of is H2SO4 produces 2H plus, so you times 2. Okay, so you get 1.81. This one, okay, what you probably do is you find the concentration of OH minus. Remember, calcium hydroxide has 2 OH minus, is CaOH2. Okay, so times 2, and then you find the BOH. Then you do 14 minus the BOH to get the pH. Note that people seldom put the pOH value of a solution. They always put the pH value. So you need to do this last step. Okay? Okay, so I will continue here from the